So in this lesson, unfortunately, it's not a real lesson. We are not going to code right away. We are going to talk about the webGL and why we should use Three.js. Don't worry, it's not that long, and I think it's going to be interesting. You need to know those things. Well, you probably already know what Three.js is. All right, but let's talk about it and why we need it. Three.js is a 3D JavaScript library that enables developers to create 3D experience for the web. All right, it's for the web. The good thing is that you can use the web for almost anything, so it's great. It worked with webGL, so we are going to talk about webGL, but you can make Three.js work with SVG, CSS and stuff like that. Yes, you can do that. Most people using Three.js don't know about it because they don't really need it, but trust me, you can make Three.js work with SVG and CSS. You won't get the same result. It won't look as good, you will have performance issues, but still know that you can do that. We are not going to do that. We are going to focus on webGL, Three.js to create webGL experiences. All right, let's do some showcase. It's just websites I really want to show you. Some I've made, some I didn't make, some made like long time ago, and some just made few days ago that I think are just great. I want to show you what you can do with Three.js. So the first one is kind of obviously my portfolio. I won't spend too much time on this one because you already know about it. I will just increase the size a little. Yeah, something like that, it's enough. So this is just my portfolio. You can just create your portfolio in webGL. It's a good way to practice. It's a good way to showcase what you can do and to let people just enjoy, have fun. All right, let's not spend too much time on this one. You probably already know it. The next one, I think it's just like beautiful. This is like one of the best experience I've seen. It looks just great. It's Corn revolutionized. It's a Pioneer. It's just beautiful. Look at that. It looks great. The performances are good. It can be a little slow on bad computers, but for that kind of render, they did such a great job. So yeah, it's really unbelievable. And see those text here, where those texts are made in webGL too, with those animations. So yeah, it looks really cool. Look at this field. That's really awesome. Oh, by the way, all those links, you can just click on the links panel on the top right corner of this page you are looking at. Open the links panel, click on the links, and you will be able to enjoy it. Be careful, by the time you see those websites, maybe some of them, by the time you see this video, some of them don't exist anymore. If it's the case, well, just look at my screen, and I will keep these links updated. So check the links. Maybe I will add some more in a few months or something like that. All right, next one is let me check. Yeah, this one. Yet again, it's for a portfolio of Richard Matka. Sorry if I said it wrong, but I think it's just cool. Like he did a background in webGL. Keep the page open, keep looking at the shape, and you will see that it will change and it looks just great. It's just awesome. Illusion by Edan, obviously. The portfolio is just like a huge showcase of pushing the possibilities of Three.js and the webGL to the maximum. Have a look, check the other page. All right, have a look to different page. You will find so much good thing in that one. Next one is a pretty recent one. It's for a game. It's for a VR game. It's Medal of Honor. I think the name is Above and Beyond. And what better than doing a webGL website for a 3D game, so that you can kind of enjoy the same experience. It's maybe not as good because this is not a VR, it's just like in the web page, but still you will see how great it is. So this is a video. I will just skip the video and go straight to the experience. I just want to showcase stuff. You will see why. So as you can see, right now it's just an image in the background. It is. It's not an image. Look at that. The feeling you get when you see that image, you're feeling like, oh yeah, that's a good image. And then you scroll and you're like, wow, it's just explode to your face that it's not an image. This is 3D. It's a lot of painting on 3D models. So they did a great job about that, but still they did it in 3D and you can just go through this village and discover a story. Yet again, I won't show you everything about this experience. I'll let you discover those. And it's just great. And the sound design is great too. I didn't put the sound on the video, but test it with the sound. It's really cool. Next one is Let's Play. Oh yeah, one of my favorite experience. They did it for Wigo. Wigo is like a train company in France. I don't know if other countries too. Anyway, they did a pinball. I'm a gamer. I love when I can just open a web page and play. And they did something I really liked. They integrated, I have to focus, physics to their game. And I like when you have physics, you can play with the physics. I'm pretty bad to this game, so I will just lose on purpose. And it's just really cool. We are going to talk about this one again, where we are going to do some physics together. I have more to show. I wanted to put like hundreds of websites on this page, but I just had to choose, I don't know, like a dozen of website. Yeah, I put this one because first it looks great design, great webGL stuff. But it's because when you have a product, you want to showcase your product so that user can see it. What's better than having a realistic render like that? People will be, it's not just images, people will be able to rotate the model, zoom on the model, maybe see very specific part. What can I check? Maybe this one. And up, it zoom in. And I can just go back, change it, stuff like that. It's perfect. If you want to showcase your product, create it in webGL. But you will have to get a really realistic render and also performant. And I will show you how to do that, obviously. Zenny, yeah, I really like this one. Also because it looks great, performances are great, the website is not even that heavy, but it's also to focus usage of an application called Zenly, and you have like different world and you can travel through world and look at seamless it is, and we change the world like that. You have a lot of animations, great work on this one. Look at the models, they look so great. Look at the sausage. There are some little things hidden. Well, test the website as always. Next one is going to be prior. Prior, it's I don't know the English word. We say a traitor. It's a Japanese traitor, so it's for handling events, preparing the food for huge events, for wedding events, and you have something like really poetic, like it's really immersive, oniric kind of. I don't know if we can use this word, but it's oniric. And look at this ribbon. Look at the physics of the ribbon. Look at the texture of the ribbon. Look at the drawings appearing on that ribbon. And yet again, I'll let you discover like the menu, stuff like that. There are some hidden features. Next one, mid one. Oh, I really love this one. It's the colors I love, it's the style I love, it's kind of Tron style, huge cities. You start at a small scale and it becomes huge, you will see. So right now, all we have is just like a classic WebGL background. It's just a gradient. It is? No, it's not. It was the head of this little guy here. And look at that. Look at the color. I really love those colors. They did such a great job. It's by Immersive Garden. And it's so cool. There are many hidden features, hidden navigations feature. So I let you discover like the other ones. Look at the city. Look at the reflection on the ground. It's crazy. I really love this one. Probably my favorite this year. Next one. Yeah, next one. It's a game because you can create games. It's by Les Gobelins. It's a French school. So the goblins, maybe we can say. So it's just students that did that. Good job, guys. So we do new games. I will skip the intro, even if the intro is great. I'll let you discover the story. I will go straight to the game and look at that. It's looking great. And you can jump and you have to move forward, go through different obstacles. And you will gain powers, and the powers will let you do even more. You will see. You have to test on your own. And yeah, one last one. It's Chartogne. It's for a wine. How do you say wine maker? Wine something like that. I don't know exactly the name. And look at that. This is the real village where they make this wine. And you have like the parcel. Yeah, again, I don't know if it's the right word. And this is the real village. Like you really have those streets, those houses. The forest is here. It's the real name of the streets. And look at the details. There is thousands of elements in the village, and it looks just great. And look at that. If you go into a field, then you zoom in the field and look at that. This is crazy. Look at that. And you can scroll below and you get, we call that a flow field effect. And yeah, it's just so cool to create those kind of things, those kinds of experiences that surprise the visitor. Well, that's all for the showcase. I have much more website I want to show you, but still, let's try to get back to the lesson. So what is webGL? I will put that here. Well, webGL is what we call a JavaScript API. You have access to properties, you have access to methods, you have access to a lot of things, and you take those things to create stuff. All right. The idea is that you will render triangles at a remarkable speed. Like you will just draw triangles. The WebGL will draw one triangle here, one triangle here. Those triangles can have very different shapes, one here, and one big one here like that, and it will just draw triangles, but really, really, really fast. The result can be drawn in a canvas, but not necessarily. You can put the result in something else. And we will do that at a point. You will see why, but we won't draw the result on the canvas at first, so that we can do some stuff and then at the end put it in the canvas. But usually at the end you get something in the canvas because we want to see an experience, a 3D experience. It's compatible with most modern browsers. You can just use it, no surprise here. And it uses the graphic processing unit. And this is why it's so damn fast. We call that the GPU. All right, it's a component in your computer. There is the CPU and there is the GPU. When you do calculations in JavaScript, you do, I don't know, 2 plus 2. It's the CPU working. When you draw those triangles, it's the GPU working. WebGL can be used for 2D. And like really, it's really cool to use WebGL for 2D because what you can do is maybe, I don't know, draw triangles like this. Draw triangles like this. And on that triangles, you will draw a little guy, something like that. And this little guy will be your character. And then when you move you use your keyboard, you will make those two triangles move. So yes, you can use WebGL to create 2D experiences. And we are not going to do that, but you can do that. And there is libraries dedicated to that, like Pixie.js. Anyway, let's move forward. So we talk about the CPU and the GPU. The CPU can do calculations really, really fast. Like your CPU is like right now, your CPU is doing like so many calculations. It's crazy, but it's one by one. And it has to finish the first calculation to move to the next, This is not exactly true because most CPU now have multiple core, meaning it can work on multiple threads. Like, I don't know, there is 8 cores and one core will take care of your Chrome JavaScript application, and one core will take care of your video game running on the back, and one core will take care of, I don't know, you have an application open. Well, this is why the CPU can do multiple calculations. But for your JavaScript application, like you just do calculations, it will be only one CPU, all right? The GPU is not as fast as the CPU, but it will be able to do like thousands and thousands of calculations in a row. And this is exactly what we need to draw those triangles. The idea is to draw a 3D model, because at the end we want a 3D model. We are going to draw many triangles, but we are going to draw them at the right position and then colorize them so they look the way we want. The GPU will position all those points at one according to many factors. Like, let me remove this. The idea is that we are going to draw, I don't know, maybe a point here, maybe a point here. We are going to talk about those points. There is a lot of to know. Maybe one point, I don't know, here, maybe one here, maybe one here, maybe one here, and maybe one here, and maybe one in the back here. So it's just positioning points on the screen, on the render. I don't know exactly the screen, the render, some kind of 2D space, and then it will draw. Let me use, I don't know, orange, a triangle right here, a triangle right here, a triangle right here, another one here, another one, let's say here, another one here, and look at that. We have a cube. See? We position things and we position, sorry, no, this one is wrong. So it's mostly go there, and like that. So we position points points of a geometry, something like that, according to many factors. We see that there is a lot of factors, like where is supposed to be the cube, where are supposed to be those points, if my camera, because we will have some kind of camera, is positioned like that, where they should be in some other places. So we provide a bunch of information. Those vertices get, sorry, those points, I'm talking about the technical words, but those points will get positioned at the right place according to some like program, we say what, and then they will be drawn. So once the points are placed like that, the GPU, so the GPU will position all those points at once. This is what I wanted to say initially. So maybe we have like something, maybe we have 8 points here. Actually, we have more, but maybe we have 8 points. We can have much more complex geometries with thousands and even more points. So we can have a lot of details. And this is how we draw, I don't know, maybe the face of someone in 3D, or I don't know, maybe a sphere or a house or stuff like that. We have much more points than those 8 points. Once those points are positioned where they are supposed to be, for the moment, actually, we cannot see anything. I know I draw some triangles, but when those points are placed, we cannot see anything. But now that those points are placed, the GPU will draw each visible pixel of those points. Meaning that if this is supposed to be, let's say, on the screen, well, your screen is composed of pixels, something like that. So it's huge pixels, obviously, so that we can understand. But we get like pixels like that. And then the GPU knows that there is a point here, a point here, a point here. Then the GPU will draw this pixel and this pixel and this pixel and this pixel and this one and this one and this one and this one. It will continue like that. Yet again, because it's the GPU, it will do it so damn fast. Like it will do all the pixels at once, maybe. If not, maybe in 2 times, so that it handles all the pixels, but just in two iterations, we will say. All right, this is the idea. And this is why your GPU is so fast. Those instructions, like position the point here, color this pixel that way, are inside shaders. Those instructions to colorize and position the points are inside what we call shaders. And shaders are really hard. And we are going to learn shaders together. But you will see, so shaders are really hard. As you can see, it's kind of complex. We have to position points, we have to colorize them, we have to draw, to write instructions in those kind of programs that we call shaders. It's getting hard. What are you going into right now? Don't worry. We provide a bunch of information to those shaders, like the point position, the model transformation, the camera coordinates, and things get positioned and colorized the way we want, which is exactly what I did before. All of this is so hard. Drawing a single triangle on the canvas would take at least 100 lines of code. And I did it when I tried to learn webGL. I tried to learn webGL, native webGL. And it took me more than 100 lines of code to draw only one single triangle on my canvas, on the screen. It was too hard. I was like, no, I could never do those kind of WebGL experiences. It's impossible. But doing native WebGL benefits from existing at a low level. So you're just like talking to your GPU to position things and colorize the pixels. And this is great because you can optimize everything and have more control, but it's too hard. And this is where Three.js come to the rescue. Three.js is the JavaScript library. It's under MIT license, yay. It's right above the WebGL. So you have this WebGL, which is too hard, and right above the WebGL, you have Three.js, and not 4, which is great because we are going to be able to do some WebGL too. The creator is Ricardo Cabello, aka Mr. Doob. We mostly know him with that name, Mr. Doob. I put the link to its website and its Twitter. You should follow Mr. Doob. And Three.js will drastically simplify the process of all of this. You won't have to handle those shaders. You won't have to draw to write those shaders. You won't have to provide like each point. You can just tell I want a cube, and the cube will just show up. So it's really great. But we can still interact with the WebGL because it's right above the WebGL. At a point, we will be able to create our own shaders and send our own information. It's for when we want to go further. We want to create our own thing. We want to optimize stuff. We want to do things that 3GS cannot do. We can do it, which is great because 3GS is right above the webGL. All right, let's talk about 3GS a little more. So Mr. Doob is still working on it, but now with the help of a large community, I can give you a small preview of the who did work on it. So it's on GitHub. You can find the 3GS on GitHub, and as you can see, like all those people are working on 3GS, so it's just great. So look at that, huge community still working on 3GS, a lot of people. So thank you to all these people helping the 3GS project. The library gets updates every month, so this is cool. And you get for each update a change log, so you know what has been updated. And this is just one update. And this is another one update. And as you can see, there is a lot of things changing. Do not worry. It should be the same for you. Maybe there will be some differences in the lesson and for your version, but I will try to make to update things accordingly. The library is pretty stable. All right, this is mostly like detailed features, new method, stuff like that. There is no huge changes because right now the library is really stable. So it's some small bug fixes and optimizations and new features, usually. You can discover many exceptional projects on the homepage right here. So just check those projects. We already seen some of them, like this one. But yeah, check those projects. This one is really cool, obviously. So yeah, have a look to those. This project is getting updated regularly. There is a well-maintained documentation. The 3GS documentation is really cool. Like you can really use it. I put the link to the creating a scene. We will do that in the next lesson together. But if you want to have a look to the documentation, please do. We have many examples, and they are great. Here is just one example. So look at how great a render can be, like really realistic. And look at those examples. So many examples. If you need to do something, you don't know how to do it, check the example, do a search. We have the search bar right here, and maybe we found it's going on. Look at that. I'm scrolling up as fast as I can, and it keeps going on and on. All right, so many examples. So have a look to the examples. We'll learn a lot. If you want to know about 3GS update, new projects, stuff like that, I recommend to follow, Mr. Doob. So you can follow on its account, but also there is a 3GS account, Twitter account. Follow this 3GS account, you will get a lot of updates, cool things. Follow this account. And what about other libraries? Well, indeed, 3GS is the most popular WebGL library. It's very stable, it provides many features, the documentation is remarkable, the community is working hard on update. And it's still close enough to the webGL, so we can like do our own shaders, stuff like that. We will learn what are exactly shaders and how to do that, to do them together. But there are many other WebGL libraries, and those WebGL libraries might do things differently, might have better features, might be maybe even more optimized or easier to use. Like it can be like more of a framework than a libraries. So be curious, have a look to other libraries. I won't put links because there are too many of them, but be curious. I recommend you to use 3GS, but it really depends on your need, and have a look to other libraries. And I will see you in the next lesson.